negatives. But that is easy. You'll see what I mean. Okay, so let's look at the very first problem. This is your notes. This is 4-3. And there's a handy dandy little picture drawn for you. Please do not be confused by the picture. The deal is this. In this particular problem, we have the point -3, -4. Go ahead and plot that point, or I guess I've already done it for you. I already plotted it for you. Now, connect that point to the origin, and that's what angle we're talking about. We're talking about this angle sticking down here in quadrant 3. Now, to make a triangle, we're going to raise a perpendicular straight up to the x-axis. Every triangle we draw is going to be a part of what we call the butterfly bow tie. So if we're drawing a triangle in quadrant 1, it's going to look like that. Remember, we did a lot of those yesterday. Quadrant 2 looks like this. Quadrant 3 looks like this. Quadrant 4 looks like this. So when you draw your triangle, for whatever problem you're doing, make sure that it's one of these. Okay? This is how we draw all of our triangles all the time. Okay? So this point is in quadrant 3. So I've drawn this triangle. Connect the origin to the point, and then take your line straight up to the x-axis. And there's your triangle. Now, this side is -3. Remember, we went over 3 and down 4. Now, I know in geometry, you probably, you don't like having negative sides of the triangle, and I get that, but I need to keep the negative because it's going to impact my sine, cosine, tangent, and so on. So we're going to do what we did the other day. We're going to fill all these in. But now we're going to have to contend with the negatives. Okay? Now, what's missing in this picture? Look at your triangle.
Pardon the interruption?
Yep.
Is
Yes,
Andrew Gilbert in the classroom?
he is.
Can you please send him to the admissions office, please?
Yes. Hurry back.
Thank you.
Hurry back, hurry back. All right. So what's missing in this triangle?
An extra angle.
I don't know what this is, right? How did we do this the other day? Please don't let the negatives bother you. How did we find that third side the other day? Exactly, the Pythagorean theorem. So we have 3 squared plus 4 squared equals c squared. This is what happened to the negatives. Remember, we're squaring. So what does happen to the negatives? What are you doing? You all right? So when you square a negative, it disappears, right? So let's not even include them when I'm doing the Pythagorean theorem. They're going to be gone. So 9 plus 16 equals c squared. So did you get 5? Remember, your hypotenuse is always positive. A and B can be negative depending on where you are in the coordinate system, but the hypotenuse is always positive. Always positive. In terms of the triangle, and this angle right here, we always look at the angle of the origin. Which side is this? Opposite, adjacent, or hypotenuse? Opposite. And this is adjacent, and this is hypotenuse. So can we fill in our chart? Absolutely. What sign? SOHCAHTOA. Write that down on your paper if you need to. SOHCAHTOA. What is that? SOHCAHTOA is opposite over hypotenuse. So opposite over hypotenuse will be -4/5. When you put your different quadrant, things are negative. Cosine, what's my cosine? Which will be negative 3/5. And what's my tangent?
Opposite over adjacent.
Which is,
-4 over -3.
so the negatives are gonna cancel, and the tangent is actually gonna be a positive number? Because opposite and adjacent were both negative? And then what do we remember about these guys? What are these guys? The reciprocals of what we started with, so -5/4, -5/3, and +3/4. There is nothing different about this problem than the ones we did a couple days ago, except now I have to deal with negatives, because now I'm in quadrants other than one. Alright, any question about that? These take so much space, I'm gonna have to race to do the next one, we okay? Alright, so let's look at the next one. Where's our point? Don't let my picture confuse you. Where's your point? 1, -2? So I told you to connect it to the origin, and then take your perpendicular right up to the x-axis. So there's my triangle this time. Here's the origin. I went over 1 and down 2. Does that make sense? So now what do I have to figure out? Same thing I did last time. I have to figure out my hypotenuse. So I will do my Pythagorean theorem. Don't worry about the negatives. 1 squared plus 2 squared equals c squared. Kids, we're squaring, so the negatives are going to disappear anyway. This time I got the square root of 5 for my hypotenuse. Is that what you got? The angle is always at the origin. So which side is the -2? Opposite, adjacent, or hypotenuse? Opposite. Adjacent. Hypotenuse. Alright, now we can fill them in. Sine. Root 5? We'll fix that in a minute, but that's how it starts, right? -2 over root 5. Cosine is positive 1 over root 5. Tangent, -2 over 1. Opposite over adjacent. Now let me flip these things. So I get root 5 over -2, root 5 over 1, and -1/2. Keeping up okay? So now I will fix anything that needs fixing. So this root 5 has to come up, so -2 root 5 over plane 5. Root 5 over plane 5, and that of course is just -2. You see how this is just like what we did the other day? Except we have to be in a different quadrant. Okay, Scout, that thing you're wearing is not uniform, honey. Can you take it off for me? It's beautiful, but it's not uniform. All right, now the next one, here we go. All right, what point am I plotting? For this problem, C, what point am I plotting? -1, 3. So I'm coming over -1 and up 3. So I connect that point with the origin and then drop my perpendicular straight down to the x-axis. Remember, the triangle you draw has to look like one of these. This one in this quadrant. So is the picture okay? All right, what do I do next? Find Pythagorean theorem to find my hypotenuse. Okay, go ahead, see if you can do that on your own. A squared plus b squared equals c squared. You just really tell Steph to take her jacket off. Can you take this off? I know it says Notre Dame, but it's not a sweatshirt. You're like a college sweatshirt. This is a college sweatshirt. Don't push it, just take it off. All right, what'd you get for your hypotenuse? No one got it?
Square root of 10.
Yes, square root of 10. Guys, how can we not get that? 1 squared plus 3 squared equals c squared. 1 plus 9. That's the square root of 10. Right? So here we go. Now I'm ready to fill in everything. All right, what's the sine? Here's your angle, so figure out which side is opposite. Which side is opposite? 3. So what's the sine? So katoa, so sine will be, so 3 over the square root of 10. I'll fix it in a minute, but that's how it starts out. Opposite over hypotenuse. What's cosine? Adjacent over hypotenuse, so that one's going to be negative because the adjacent side is -1. And then the tangent is opposite over adjacent, so that'll be 3 over -1. And then we can do our reciprocals. Cosecant is the reciprocal of sine. Remember, I won't always have these nicely lined up for you. You need to learn that the cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. And of course, cotangent is reciprocal of tangent. Now we'll go back and anything that needs cleaned up, we'll clean up. So we need to bring our root 10 up, so 3 root 10 over plane 10. Negative root 10 over plane 10, and that's -3. And this is negative root 10. Because anything divided by 1 is just itself. Are we in agreement with that, everybody? All right, one more. Oh, this one's, what's nice about this one, the point is 4, 5. What's nice about this? It's all positive. Everything is positive. Over 4, up 5, there we are. Everything's positive. Because we're in quadrant 1. Your angle is right here at the origin. That's always where your angle is. It's always here, or here, or here, or here, depending on which quadrant we're in. So, let's try this again. Do the Pythagorean theorem and tell me what you get for your hypotenuse. And I'll say it again, the hypotenuse will always be positive. No matter what quadrant you're in, the hypotenuse is positive everywhere. All right, what do we get? I think we get another radical here. 41, square root of 41, perfect. Hopefully you're starting to fill things in. What's the sign? Five over root 41, and I know that needs fixing, we'll take care of it in a second, but it starts out opposite over hypotenuse, 5 over root 41. What's the cosine? 4 over root 41. And what's my tangent? Opposite over adjacent, so it'll be 5 over 4. Then I can do my reciprocals. And then if there's anything that needs fixing, I will fix it. And I think it's just these two. Anybody have a question about any of that problem? Well, here's the good news then. The next problems are exactly the same. Exactly the same. In problem 2A, the point is 2, negative 2. So what do you think I'm going to do? I'm going to plot it. That's right. I'm going to go over 2 and down 2. I'm going to connect that to the origin. And then I'm going to go straight up to the x-axis. And there's my triangle. So this side is 2. I went over 2. This side is negative 2. I went down 2. It's exactly what we just did. So what's the next step? Find the hypotenuse, Pythagorean theorem. So go ahead. This one's going to be a little bit tricky. Go ahead and find it. Tell me what you get when you do this Pythagorean theorem. I'm not sure this has happened in our examples. Taylor? What?
0.
Oh, no. Remember, the negatives square out, Taylor. There should never be any negatives. So it's going to be 2 squared and 2 squared. So the square root of 8. Now, what is different about the square root of 8 compared to like the square root of 41 that we had in the last problem? This one actually simplifies. How does the square root of 8 break down? 2 square roots of 2. That's exactly right. Remember that deal? We haven't done it for a while, but remember when you do this and whatever you have 2 of comes out? Whatever you don't have 2 of stays in. So 2 comes out, 2 radical 2. Now that's going to make, that isn't going to change the trigonometry, but it's going to make my simplifying a little bit tricky. Here's, you do it the same way. Which side is opposite? This is your angle. Which side is opposite? The side, or the negative 2 or the positive 2? Which of those sides is opposite? The negative, this is opposite. So negative 2 over 2 root 2. Now I'm going to come back and simplify that for sure. But right now, would you agree that's what I'm starting with? Opposite over hypotenuse. All right, what about cosine? adjacent over hypotenuse, so it'll be the same thing but positive, 2 over 2 root 2. And what about tangent?
Opposite over adjacent.
So negative 2 over 2. Now all that needs cleaned up. Okay? But I'm just gonna do my flipping and then I'll simplify. So when I flip this, I get 2 root 2 over negative 2, 2 root 2 over positive 2, and 2 over negative 2. Now I'm going to stop here, because everything else after this is just a little arithmetic. Are we good with the setup so far? Okay, then let's talk about how to simplify this thing. Now there's a 2 over a 2, right? I can cancel those. So this is negative 1 over root 2. Well, I can't have a radical in the bottom, so I'm going to make that negative root 2 over 2. That is the sign value. Let's go through those same steps with this one. 2 over 2 is going to cancel. So now I have 1 over root 2. Get rid of the radical in the bottom, bring it to the top and have a root 2. There is the cosine. And of course the tangent's just negative 1, right? Now same thing over here. Will these cancel? Yep. So that's negative root 2. All I have left on the bottom is a 1, so it's just negative root 2. Positive root 2 and negative 1. So the trig was the same. We had to do a lot more arithmetic that time.
For cosine, why would it be root 2 over 2 if it's 1 over 2?
Because you have to rationalize it, so you multiply the top and the bottom by root 2.
Oh, okay.
You don't like radicals on the bottom. Alright, let's see if you can draw your triangle for problem B. Problem B is the point negative 1, 4. So plot your point and see if you can draw your triangle. Make sure it's one of these guys. So negative 1, 4. Mine's kind of slanted there. Is that what you got? Does yours look like that? So what's the next step? Pythagorean theorem. And what will that be? Let's figure that out. Remember, when you square, it's positive. Everything's positive. Square root of 17. Remember that the hypotenuse is always positive. Your triangle can have negative parts depending on where you draw it, but the hypotenuse will always be positive. What'd you write down for your sign?
4 over.
Yep. That's perfect. That's perfect. What about cosine? Adjacent, which would be right here. So negative 1 over root 17. And what about tangent? What is your tangent going to be? 4 over negative 1. Now I know we have some work to do there, but let's go ahead and do our reciprocals. So cosecant, root 17 over 4, root 17 over negative 1, and negative 1 over 4. question about that. That's the basic setup. We still have some work to do, but that's the basic setup. Everybody, like, sort of got that? So let's rationalize. So your final answer for root 17 over 17, negative root 17 over 17, and negative 4. And this one's negative root 17. Okay, so Kamari's here just in time for the action now, because things are about to get wild and wacky. Look at the next point. And tell me what is different about it. Where is it? It is right here. Now, why does that make things different? Well, remember, you're exactly, Geo, you can't make a triangle. Remember, you're supposed to join it to the origin, and then take a perpendicular to the x-axis to create one of those pictures. Can you create one of those pictures from that point? No. This angle is what we call quadrantal. And all that means is when you plot it, it's actually on an axis. It's not sticking out here in the quadrants, it's actually on an axis. So it could be any of these. This one happens to be right here. But the directions are the same. We're still supposed to find sine, cosine, tangent, and all that stuff. But a triangle isn't possible. Get out your purple sheet, if it isn't already. And there's something on the purple sheet that we have not used yet. We've done the 30, 60, 90. We've done the SOHCAHTOA, opposite over hypotenuse stuff, but who sees something on the purple sheet that we haven't done? Well, no, on the front. We haven't done the back side for sure, but on the front side, who sees something that we haven't talked about yet? We haven't talked about, on your definitions, when it says sine theta equals, it says y over r, and it says opposite over hypotenuse. Each of them has like 2 definitions. And we've done the opposite over hypotenuse, opposite over adjacent. We've done those. We have not looked at the y over r thing. When you can't draw a triangle, and that will happen any time that you're one of these points. When you can't draw a triangle, you draw a circle. When we say that sine equals y over r, what do you think that r stands for? Radius. And when I drew this circle, and notice you draw it through your point, wherever your point is. So I drew that circle around there. What is my radius? 2. So for this picture, not every picture, but this picture, my radius is 2. This point was given to me. This is the x, and this is the y of the point. So I know that x is 0, y is -2, and r is 2. Looking at the definitions, can we now fill all these in? Yeah, sine is y over r, so -2 over 2. What's cosine definition? X over r. So that's 0 over 2. We'll fix all these in a minute, but for now, we're just writing down the fractions. What's tangent definition? So y over x. Ooh, that's bad news, but go ahead and write it down. Now, the reciprocals work the same as they always have. So 2 over negative 2, 2 over 0, 0 over negative 2. Now, just about every single one of those needs simplified. What's negative 2 over 2? Negative 1. What is 0 divided by anything? 0. What is anything divided by 0? Undefined, right? You can't divide by 0, or as Hollis says, you can't sit on the egg. So a 0 on top is 0, but a 0 on the bottom is always undefined. Okay, do the same thing over here. What's 2 over negative 2? What's 2 over 0? Undefined. And what's 0 over negative 2? There we go. Okay, so let's just take a deep breath here. What's the moral of this story? If your point is not sticking out here in a quadrant somewhere, then you can't draw a triangle, and you're going to have to draw a circle. As soon as you plot your point, you'll know what your radius is. The point itself is the x and y, and then you just set up your fractions.
So you just counted for the distance from the origin to the circle to...
Yeah, this is the point 0, negative 2, so I went down 2.
It's all positive.
Radius is always positive. Radius is always positive. Just like in the picture, in the triangles, the hypotenuse is always positive. They're kind of the same thing, because if I drew a circle around here, isn't the hypotenuse like the radius? Yeah, always positive. Always. All right, let's try 3, 0. The point 3, 0. The point 3, 0 is on an axis. It's on an axis. It's not out here. It's straight on an axis. Because of that, we're going to draw a circle. What will be the radius of that circle? 3. And we know from our point that x is 3 and y is 0. That's just given in the point. I don't have to figure that out. That's x, that's y. So now I can fill in stuff using these are called the circular definitions. The ones that have r's in them, radius, are called the circular definitions. So y over r would be 0 over 3. X over r would be 3 over 3. And y over x is 0 over 3. So far, so good? Now we'll flip them. So 3 over 0, 3 over 3, 3 over 0. And then we'll clean up pretty much everything. What's 0 divided by 3? 0. What's 3 divided by 3? 1. And 0 divided by 3. Here, what's 3 over 0? Undefined. Now you can write the word undefined, that's what I did last time, or you can do an empty set symbol if you prefer. That means it does not exist. You can write DNE, does not exist. Somehow indicate there's no answer. 3 over 3 is 1, and 3 over 0 is another, does not exist. Undefined. guys, we're getting close to the big important part of this. We just have to have school tomorrow because we've got to get to this big important stuff. Okay. All right. We got it. When do we use a circle instead of a triangle? When it's on an axis. So if you plot your point and you plot it out here, whatever your point is, you're gonna make a triangle, right? But if you plot your point and it's right here, then you're gonna make a circle. If you make a triangle, you use the opposite over hypotenuse definitions. But if you make a circle, you use the y over r definitions. All right, so what's going on in the next problem? It says I got an angle between pi over 2 and pi. And I have to figure out if the sine, cosine, and tangent are positive or negative. Now, have we had this morning sines, cosines, and tangents that are positive, and then sines, cosines, and tangents that are negative? Yep. What did that depend on? Where it was. Where it was. So here's what I want you to think about. A couple of new pieces of information. I don't think we've talked about this before. In regular trigonometry, not navigation, in regular trigonometry, 0 is here. And the angles are measured counterclockwise. So this is 0, this is 90, this is 180, this is 270, and then all the way back around is 360. So it goes this way. Now I know what you're thinking, because we took a quiz yesterday, and I asked you to draw an angle, and this is not where you started. Where did you start yesterday? Up here. If, don't get mad, I didn't write the rules. If it's a navigation, if we're doing a course, a heading, a ship is sailing, an airplane is flying, then we use the compass. And the compass looks like this. But the only time we use the compass, the only time, is in a navigation problem. If it's a straight math problem, then this is the setup you use. This is important. Now, your job is to find this area of the graph, of the Cartesian coordinate plane. What's pi? 180. So what would pi over 2 be? 90. So in other words, they're asking you to look between 90 and 180. So in this setup, where am I looking? If I'm between 90 and 180? Right here. We call it quadrant 2, right? And the triangle in quadrant 2 looks like this, just generally. That's the generic triangle for quadrant 2. If I were going to plot that quadrant 2 point, tell me about this side of my triangle. Now I don't know how long it is, but what do I know about it? It's going this way. So whatever it is, wouldn't that have to be a negative number? In quadrant 2, isn't the x side negative? And then what about this side? Positive. And what about my hypotenuse? Always positive. So here's my angle. The opposite side is positive. The adjacent side is negative, and the hypotenuse is positive in that location. So if they want to know if the sine is positive or negative, we don't want to know what number it is. We just want to know if it's positive or negative. Remembering that sine is opposite over hypotenuse, wouldn't that be positive over positive? which is gonna make it positive. Are you sort of getting it? It's kind of confusing. So let's look at cosine. What's cosine in terms of a triangle? Cosine is adjacent over hypotenuse. So that would be negative over positive. So in that quadrant, cosine is negative. What about tangent? Negative. Tangent's also negative because it's opposite over adjacent. That's a little bit tricky, and there's one more of them, so we'll do one more. So here's our setup, always in straight math. So problem B says pi to 3 pi over 2. Okay, where are we looking then? Well, what's pi? 180. 3 times pi divided by 2.
About like 4.7. Wait, 3 times 5?
3 times 180.
Oh, sorry.
Yeah, we're changing it to degrees. It would be, that would be the decimal equivalent of it. That would be the radian measure. The degree measure is 270. So on our framework here, where are we looking if we're between 180 and 270? Down here? So we draw our triangle down here. Remember your butterfly bow tie. Here's your angle, always right there at the origin. Tell me about these sides. I don't know any numbers, so just tell me positive or negative on those sides. They're all positive? They're all negative. This one is never negative, so that one's gonna be positive. But are these both negative? They sure are, because from the origin, didn't we go left and down to plot that point to get down there in that quadrant? So left and down are negatives. Okay? So I want to know, am I positive or negative for my sine, cosine, and tangent? All right, so here's my angle. So this is opposite, adjacent, hypotenuse. We've done that a lot. Is everybody okay with those labels? So now I need sine, opposite over hypotenuse. What's going to happen? That's going to be negative. What about cosine? Adjacent over hypotenuse is also going to be negative. And what about tangent? Opposite over adjacent, that one's actually going to come out to be positive. All right, we got one more set of problems here to do. Keep in mind our framework. I'm going to put it up here again. Tell me where 152 is. Where's 152 degrees? I'm looking at problem number 4A. Wouldn't 152 be in here? All right, so there's a triangle for 152 degrees, because 152 is between 90 and 180. In this triangle, remember this is your angle, in this triangle, tell me about the sides. Right here, positive or negative? Positive. Here, positive. Here, perfect. Now, For this particular problem, I only want the SIN. Only want the sign. So sine is opposite over hypotenuse. So the sign of the sign is going to be positive. Because it's plus over plus. All right, what about 8 pi over 9? Can you figure out how many degrees that is? What do we do to figure out how many degrees that is? 8 times 180 divided by 9?
160.
160? Where's 160 in my setup here? Oh gosh, is it the same place, basically? So this time I want the cosine. So the angle happens to be coincidence, happens to be in the same quadrant. I can use the same picture. Cosine is adjacent over hypotenuse, so the cosine will be negative. $300. Where's 300? Right in here. So I'm going to draw that triangle. This is the triangle for 300 because 300 is between 270 and 360. In this quadrant, I know the hypotenuse is positive because it's always positive. What about this? Positive. Negative, going down. I want the tangent. Tangent, here's your angle. Tangent is opposite over adjacent. So that's gonna be negative. The tangent of 300 is a negative number. 15 pi over 8. I have no idea what that is. Can somebody help me out? 15 pi over 8. 337.5?
Yeah.
So coincidentally, isn't that kind of in the same spot here? Same general area? So I want the cosecant. What's cosecant? Reciprocal of sine. So in my head, I'm thinking sine is opposite over hypotenuse. So cosecant will be hypotenuse over opposite. So in that triangle, the hypotenuse is positive, but the opposite is negative. So the cosecant will actually end up being a negative number. All right, I'm gonna stop here soon. We gotta do E though. What's different about E? The angle is negative. So here's our framework, guys. This is our math framework. And angles go this way. But if the angle is negative, it actually goes this way. It still starts here because this is 0, but it goes down and around. So think about that for a second. Every quadrant is 90 degrees. So if I'm going 200, don't I have to go to here and to here and then a little bit more? This would actually be negative 200. I'm going in negative direction. So negative 90, negative 180, and then a little bit more to get negative 200. Quadrant 2, that's positive. Positive, negative. What do I want? I want the cosine. This is your angle, remember. Adjacent over hypotenuse will be negative. Pi over 11. Tell me about pi over 11. What is it?
16.
16. Where's 16 degrees? In our framework, where's 16 degrees? Isn't it in here? And what do we know about things in quadrant 1? In quadrant 1, everything is positive. I don't even need to draw a picture. It's positive. If I'm in quadrant 1, I'm positive. Cotangent 500.
Excuse me, wanted to give everybody a freshman back bracket, golden panel update.
Okay.
This morning's matches, we see Jimmy Langfeld move forward, and we've also seen Braden Mann move forward in the freshman bracket. Matches will continue.